Imagine a world where waiting lists for organ transplants are a thing of the past, where patients no longer have to endure the physical and emotional agony of prolonged suffering. A world where we can create human organs on demand, tailored specifically to each individual's needs. This may sound like the stuff of science fiction, but thanks to 3D bioprinting, this may soon become a reality. But before we start, do not forget to subscribe to the channel, publish it, and press the like button, as this helps us a lot in publishing more wonderful inventions and more technology. Over the past decade, we have witnessed remarkable advancements in 3D printing technology. From printing simple objects to complex structures, we are now at the cusp of a major breakthrough: the ability to print human organs. This has the potential to transform the landscape of medicine and offer hope to millions of people in need of life-saving treatments. The evolution of bioprinting. Bioprinting, the process of creating three-dimensional structures using living cells, has come a long way since its inception. Initially, scientists focused on printing simple tissues and structures, such as skin and blood vessels. However, with advancements in technology and our understanding of cellular biology, researchers are now pushing the boundaries of bioprinting by attempting to create more complex organs, including hearts, lungs, and even the brain. So, how does it work? Well, scientists and engineers are combining their expertise in tissue engineering, biomaterials, and 3D printing to create living, functional organs layer by layer. By using a bioink composed of living cells, growth factors, and supportive materials, they can mimic the complex architecture and function of natural organs. The process involves precise deposition of cells and materials, guided by computer-aided design (CAD) models, to construct organs with incredible precision. What are the challenges? One of the primary hurdles is recreating the intricate vascular networks necessary to deliver nutrients and oxygen throughout the printed organ. Researchers are working on developing techniques to incorporate blood vessels into the printed structures, which will be crucial for the long-term survival and functionality of the organs. 2. Materials and bioinks. The success of bioprinting relies on the development of suitable biomaterials and bioinks. Bioinks act as the ink in the printing process and consist of a combination of living cells, growth factors, and supportive materials. These bioinks must be carefully engineered to provide an optimal environment for cell growth, differentiation, and tissue development. Researchers are constantly exploring new materials and refining existing ones to enhance the quality and functionality of the printed organs. 3. Ethical considerations and future implications. As with any groundbreaking technology, bioprinting raises ethical questions that need to be carefully addressed. Discussions around organ sourcing, accessibility, equity in healthcare, and potential misuse of the technology are crucial to ensure responsible and equitable implementation. Furthermore, the widespread adoption of bioprinting could revolutionize organ transplantation, significantly reduce waiting times, and save countless lives. 4. Regulatory and safety standards. As bioprinting approaches clinical applications, regulatory frameworks and safety standards become paramount. Establishing guidelines for the production, quality control, and safety assessment of bioprinted organs is essential to ensure patient safety and the reliability of the technology. Regulatory bodies worldwide are actively working on developing appropriate regulations to govern the field and ensure its responsible implementation. While there are still numerous challenges to overcome, such as vascularization and scaling up the production, the progress made so far is remarkable. With continued research and investment, we are confident that we will see widespread clinical applications of bioprinted organs within our lifetime. What are the benefits of printing human organs? 1. Addressing organ shortage. One of the most significant benefits of bioprinting is the potential to overcome the shortage of donor organs. Currently, the demand for organs far exceeds the available supply, resulting in long waiting lists and a significant number of patients who do not receive timely transplantation. Bioprinting can provide a solution by enabling the creation of organs on demand, reducing wait times and saving countless lives. 2. Customization and personalization. Bioprinting allows for the customization and personalization of organs to suit individual patients. Each person's anatomy and physiology are unique, and traditional transplantation often faces limitations due to the lack of suitable donor organs. With bioprinting, organs can be tailored to match the patient's specific requirements, such as size, shape, and biological compatibility. This customization enhances the compatibility and functionality of the transplanted organs. 3. Reduced risk of rejection. Traditional organ transplantation carries the risk of rejection, as the recipient's immune system may recognize the transplanted organ as foreign and mount an immune response against it. Bioprinting offers the advantage of using the patient's own cells or compatible cells, minimizing the risk of rejection. By printing organs using cells derived from the patient's own tissues, the immune system is less likely to recognize the transplanted organ as foreign, reducing the need for immunosuppressive drugs. 4. Elimination of organ waiting lists. The ability to bioprint organs on demand has the potential to eliminate organ waiting lists altogether. Patients in critical condition who urgently require organ transplantation could receive timely treatment, reducing mortality rates and improving patient outcomes. Bioprinting can significantly alleviate the emotional, physical, and financial burden faced by patients and their families during the waiting period. 5. Advanced therapeutic options. Bioprinting offers advanced therapeutic options beyond organ transplantation. Printed organs can serve as models for drug testing and development, enabling researchers to study the effects of drugs on human tissues in a more accurate and reliable manner. This can lead to more effective and tailored therapies, reducing the reliance on animal testing and expediting the drug discovery process. 6. Potential for regeneration and repair. In addition to transplantation, bioprinting plays a vital role in the field of regenerative medicine. By creating bioengineered tissues and organs, scientists aim to develop treatments that can stimulate the regeneration and repair of damaged or diseased tissues. Bioprinting offers a precise and controlled method of fabricating complex tissue structures that can integrate with the patient's existing tissues and promote natural healing processes. 7. Education and training. Bioprinting also has educational benefits, particularly for medical training. The ability to print realistic organ models allows medical students and surgeons to practice complex procedures, refine their skills, and enhance their understanding of human anatomy. This technology can revolutionize medical education and contribute to the training of future healthcare professionals. 8. Reduced surgical complications. Bioprinting can help reduce surgical complications associated with traditional organ transplantation. By creating organs with precise anatomical structures, surgeons can perform more accurate and successful transplant surgeries. The ability to print organs with intricate vascular networks also facilitates better blood flow and reduces the risk of post-operative complications. 9. Accelerated drug development. Bioprinting human organs provides researchers with a powerful tool for drug development and testing. By replicating the complexity of human organs, bioprinted tissues can mimic their physiological responses to drugs, allowing for more accurate preclinical testing. This can lead to faster and more efficient drug development processes, ultimately benefiting patients by accelerating the availability of safe and effective medications. In conclusion, bioprinting human organs is a rapidly evolving field with enormous potential to transform healthcare. The collaboration between scientists, engineers, medical professionals, and regulatory bodies is driving the progress and opening up new possibilities. Thank you for joining us on this journey.